Hello everyone. So we have a really nice geometry problem. This was AMC 12 question. So we have a square and then there is a circle center at E, has a radius of R, and the side of the square is given S and both are rational number. Circle passes through D, which is right there, and that lies on BE. Okay, this is important. So the D lies on BE. B is right here, E is right here. So it looks like I probably like to connect these two because that will make a straight line. And then F is on the circle on the same side of BE. Okay, so that is right there as A. Okay, which is basically on this side, which is given already. The segment AF is tangent to the circle, right? Okay, this is the tangency point. Whenever you have a tangency point, it's good to connect those. That is usually helpful. And then AF is given. So this guy is 9 plus 5 root 2. So, under square root. That doesn't look nice because you have already radical and then there is another radical. This is a geometry problem, so there shouldn't be too much algebra going on. But at the end, we are looking for the ratio of the R to S. Okay, so a couple things we can try. The first thing we can try, this is a square, right? And then this is a straight line passing through right diagonal, which reminds me these guys is like 45 degrees. So that might be useful because special triangles are always good. Okay, and then we got that. But at the same time, I'd like to know somehow related to this side because this is given. And I don't want to deal with this radical, especially like nested one. But I do know this is also 90 degrees, so it's good to write those. So maybe I should have some sort of triangle that includes this as one side. So I can use maybe Pythagorean to get rid of this at least the square root. But how do we deal with this, right? Maybe I can connect A to C. That will make a right triangle right here. So let's do that. So when I do this, that is 90 degrees and this is 45. That means this is also 45. Actually, no, we don't know that piece. So we know this is 45. That is good. This is also 45. But we don't really know this yet. Okay. Then what else we can do, right? So let's write this is R and this is R. And this side was S. So this is S. So if you remember 45, 45, 90, the diagonal will be this leg times root 2, or you can use just Pythagorean. And the half will be S times root 2 over 2. So this is also the diagonal, the half of diagonal. That will be the case as well. So you can just write it. So let me just read S root 2 over 2. Again, this is the half of the diagonal, which is same as this one, same as this one. Okay, so now we have this, but it doesn't look like really fine yet, but I think I should use this guy as a right angle triangle side. So maybe connecting A to A to E looks good idea. The reason why it's a good idea, there's a right triangle right here, and then I know this leg, I know this leg, even though I know some like unknown. And then on the other side, that is also another right triangle that is having the hypotenuse as AE. So if I use a Pythag for both, so in this triangle, like AFE, so the square of this leg will be just 9 plus 5 root 2. Okay, plus the square of this leg will be R squared. And that will be equal to square of AE. And then if I want to write another Pythagorean in this side, this is also, this leg is S root 2 over 2. I need to square that. If you square this guy, you got S squared times 2 over 4. So that will be S over 2. Okay, and then I need to add these two, which will be like S root 2 over 2 plus R. That is the sum to the second power. So I hope that is clear. Okay, so I just squared this leg. So it would be, that would be the S over 2. So since both of them equal to like AE, to the second power. So I can say this is equal to this guy. So let's take those into consideration. So 9 plus 5 root 2 plus r squared is s over 2. And if you expand this guy, so this is like binomial to the right, second power square binomial. So you take the square of this, which would be s over 2 as well, plus 2 times of these two products. So if you multiply this by the r and then double it, so this 2 and that 2 will cancel. You got sr times root 2 and a square of the r. So we may cancel these r squares. That is good. And the left side we have 9 plus 5 root 2. And this is good. The 2/2 s will be just 1s. And then that will be sr times root 2. Okay, so we have some information right here. We are told both of these are rational number, which is actually useful. Otherwise, we cannot really go anything from here. So we have s plus sr root 2 equals this number. So if s and r is rational, the product of rational is rational. So the number s is rational. So only way to get this 5 root 2 is the in front of the root 2 has to be 5. So sr has to be 5. So we can get 5 root 2, 5 root 2. The s has to be 9. Because that's the, let me see if I miss anything. Okay, so that is r squared. So that looks like, yeah, it looks good. So if this is 9, yeah, it looks like this is that s or s squared? Actually, this was s squared, because if you remember, we got the square of this guy, which was s squared times 2 over 4, which is half of s squared. So that was actually s squared, the same as right here. So the s squared will be 9. Because when I see this is like s equals 9, it looks too big. So that was kind of concerning based on the radius, because that will be 5 over 9, which is like kind of not good to see. That's why I was kind of confused. But now it's good. So the s has to be 3 because we cannot choose the negative version. So the r will be 5 over 3. So if you have this, we are looking for the r over s, which is 5 thirds divided by 3 is 5 over 9. I think this is the answer. So this is one thing we can do. I hope that makes sense. But the second thing I will do is actually something we call power of points. What does that look like? So for those of you who don't remember, maybe it's good to remind. So whenever you have a circle, and then let's say you have a point outside, there are 3 different cases, but one of the cases is when you have one tangent and one secant line. Okay, so this is the tangent line. So I'm going to call this is A, this is P, C, and D. The square of the P to A, which is distance between that point outside of the circle to the first intersection, which is PA, times the distance between this to that again, that will be PA, or PA squared, equals distance between P to the first intersection, which is PC, times distance between P to the other intersection, which is D, PD. So that is gonna be our first equation, right? So we got PA times PA equals this product, and then this is called power of points. So that is called power of points, okay? So why this is important? Because I can actually use this as well. Since we are told this is a segment, right, that is touching the circle at one point, which means AF is a tangent, which looks like PA. And then since this one number wasn't that great, so I should have square of this guy. So maybe that is another hint to use it. But to do so, I need to have another segment like this, which is we call secant line, that is touching the circle at 2 points. Only thing I can use probably AD. If I extend this AD in a way that I will touch the circle at 2 different points. So I have this now. Okay, and then the rest is kind of similar to the previous approach. Let me add some stuff that we had. So if you kind of remember these guys, maybe I don't need this part, but let's say, let me pull this back. So since this is 45 and this is 45, and then when you connect the center to the chord, which would be perpendicular, right? So this is gonna be perpendicular, so that will be perpendicular bisector of this chord. And then this is R, and then this is 45, this is 45, this is 45, which means this is 45, 45, 90. So the leg will be R divided by root 2. And then this is also like this piece is also R divided by root 2. So this leg is the same as this one. But the other piece also R divided by root 2. And now we know this is S. So now we can use our power points. So the square of the AF, maybe I'll just write the first. So the AF to the second power equals, that's the distance between the point outside of the circle to the first tangent point, and then you multiply this 2 times, that's basically PA squared, and equals the distance between this point to the first intersection, which is AD, times the distance between A to the second intersection, which is AT. So AF to the second power, if you square that, so you will get 9 plus 5 root 2 equals AD is S. And then AT is not that great, but we'll see S plus 2 times of R over root 2, which will be 2R over root 2. So 2 is root 2 times root 2, which will cancel the root 2. That will be R root 2. So I hope that makes sense. So if you expand these, you will get S squared plus S times R, SR times root 2. So that is equal to 5 root 2 plus 9. But if you remember, this was the exact same equation that we received in our first solution. So the rest will be the same after getting this one. So I just like to remind the power of points relation that we have. And then this was one of these. So it's good to know as well. So I hope that makes sense. I'll see you in the next video.